Alright, here we are in lesson 4, checkpoints. And another feature of this lesson is the game controller. Let's go over the scripts that's been added. We still use our mobile box controller. No changes there. Still have our spawn point limit Y script. Our push controller is still attached to our player. We've organized things a bit here in the hierarchy, and we've introduced a checkpoint. A checkpoint is just the box collider on an empty transform with checkpoint script attached. We'll take a look at that in a second. We're familiar with our game board, which is becoming a little static. We'll take care of that later. Now we have a new component attached to our pickup. Renamed it and recreated it in our prefabs as a broadcast goal instead of the regular goal, and it has the broadcast script attached to it. And our game controller, which has some scene names. We have 2 scenes in this case. We're going to be loading from and to how many pickups we've attained, what level or scene index is currently loaded, and how many pickups that are in the scene. Let's take a look here. So this is scene 2 for all intents and purposes, and it's just the previous scene with some of the items rotated 180 degrees as the parent, and they flip everything over. So checkpoints, let's take a look at that script. So checkpoint script, pretty common. On trigger enter, and here we're comparing tags instead of comparing colliders or components, and instead of using an equality operator to compare the strings. This is a Unity call, and I've heard in one of their tutorials that it's better, faster to use that, more efficient. So this is what I'll be using whenever I'm comparing tags from here on out. So here we can see we have reference to a tag utility and a player tag. So we'll go there next. Now, tag utility is just a static function, static class, excuse me, that contains some definitions. Get tag player, respawn the tag player, and get tagged game controller. So we have the game controller tag and the player tag. The player tag we use outside this lesson and outside this class, so it needs to be public. Since we're in the tag utility, we'll go ahead and we have the player assigned and the game controller assigned. Coincidentally, these are standard in Unity, so you didn't need to create them. Okay, and from our tag utility, we'll head on to our broadcast pickup script. Now, this is the script we add to our pickup game object that so it can transmit whether it's been picked up or not. So here we have an event handler, static. Anyone can subscribe to this event, and we pass in event args. Take a quick look at that. So yeah, it's a delegate that's provided by C#. It also comes without the use of the type parameter, so you can use it as such, and you're good to go here if you just pass in an empty so that would be the normal way, and the object you'll be sending is this object, so it will have the pickup and everything else, and you can access things that way. For instance, we could make the pickup public, and once we pass in this object, we can access the pickup on it if we need to use it. In this case, chose to use the pickup event arg, so we can do a rundown and see how they're used. So when we enter the trigger box, we compare the tag, and if someone subscribed to the event, we invoke it. So let's head on to the event args. It's the regular class inheriting from event args. I think this is necessary. I don't think it's just convention. So if I'm wrong, again, I apologize. It's just how I work, and that's the knowledge that I work off of. So we declare static, read only has to be either set here or it needs to be set in the constructor, so whenever this class is constructed. So then we're passing our pickup event args, which contains the pickup, to anyone subscribing to this event. Alright, so that's those four, and the final script that we have in this project is the game controller script. I did something wrong here. Oh, I'm passing in the event args, but I changed the type of the static event to the typeless event. So we need to here let it know what type of event args we're going to be using, and that way our game controller would be clear again. Okay, cool. So now here's our game controller. We start off with, we have some scenes declared that we're going to switch between. I don't think it's between, actually. Let me see it. Wraps, those. We'll find out. But these are the two scenes it will be working with. And we have a pickup counter. We have the current level index or scene index. And we have how many pickups that the scene contains. Here's a public access to our pickup and public access to our current scene name. And on enable and on disable, we subscribe and remove our subscription from the pickup event args. I do this in Unity, especially. I first remove the subscription before I add it. A lot of calls in Unity, these message calls, they happen erratically, and not often, but I have noticed that the on disable may be missed, or depending on what order things were called in, or on disable may be called twice, or an enabled may be called twice, and there's a lot of different things that go on behind the scenes which only bubble to the surface while testing and while building your code. And every instance of things happening, you can always write code around it, and that's what writing the code is all about. So this is how I've come up with a surefire fix that I will always remove myself from the subscription. Static subscriptions, something like this would retain the subscription, and it would, I think they call it memory leaks or something. So be wary. Always remove yourself from the subscription, especially from static events. Anyway, after we do all that good stuff that must be done, don't forget, then we define what we want to happen once this event has been fired. So we'll increment our pickup counter. We'll compare it, and if we've collected all of them, then we'll fire this event. Virtual method, and they're protected, so we can override them if we later and we do decide to override or implement this as a base class. So when everything's picked up, we reset the value. Now that I'm looking at it, this is not necessary, but we do it. I did it here. I wrap the index to get what index we should be on. This is a call we can check out at the top here. I glanced over it. So it takes the index and adds 1 to it and uses the modulus to return it to 0 if it's at the length that's being passed in. So if you're counting from 1 to 10 and you want to go back to 0, that function will go back to 0 instead of going to 11 and 12. It'll go from 0 to whatever number you want and redo it. So now that we've done that, we can tell what our current scene is, and we will load it. Okay, so that's what the game controller does. It's simple. It tracks our pickups so we can load new levels. I mean, show the scripts. Okay, so I'm gonna play again so I can get all the pickups. Some of them are fun, some of them are a bit troublesome. Anyway, as you can see in the scripts there's the active box controller we're going to be working on next. And I'm going to be telling you everything that I look at from down there from memory, so they may not all be accurate, but we'll be covering something of that type. Now, the active box controller gives us the ability to enable and disable input to our box controller, so we don't, like when we reload the scene, we can stop the controller, the player from giving input. And our active input manager, it does just that. Next we have game info. You notice we're collecting pickups, and so that's all game information. There's points and time that we can get from that type of information. So we'll be creating a little structure to keep all that information. Okay, I'm going to go the other way. Then we have our persistent game controller, where we can save our pickups, how many we got in each scene, so then we could maintain a score and that way. Now the persistent game controller, so yeah, it reloaded the same scene again, so it just goes from one scene to the next. So the persistent game controller uses don't destroy or unload to persist the game information. And it worked while I was building this, and it became ineffectual when I started adding more features. Like I warned about the unenable and undisable, the on level loaded or on application load level or level loaded. There's some method that's called something similar. Shift Control M brings up this menu if you're on Visual Studios. So I'm looking for the. It's not on application quit. It's something to do with when the application was loaded on, when on level loaded or on level was loaded. But that was being called twice, and it would perform the level loaded twice, and it was really messing things up. So that would be in this if you just need to persist a minimal amount of data from scene to scene. So we'll explore that in lesson 5, and we'll also create our own property attribute. So stay tuned.